Hi, welcome to this lesson on trigonometry, compound angles. In this case, double angles. So let's have a look at the cosine double angle. We know that from the cosine compound angle formulae, we derived that cos of A plus B was cos sine of AB, but because of the plus sign, we put a negative in the middle for cos. Now, if we let A equals B, so we have the same angle that we're adding, then we have what we call the cosine double angle formulae. So wherever B is, I'm replacing it with A now. So it becomes cos A times cos A minus sine A times sine A. But cos A times cos A is just cos squared A. And then sine A times sine A is just sine squared A. So we have cos squared A minus sine squared A. So that is what the double angle formulae is for cos. So cos of 2 times an angle x is cos squared the angle x minus sine squared the angle x. But we have two additional identities that we can attach to the cosine double angles that might make life a bit easier depending on the context of the trigonometric question that we're posed with. So we can extend the cosine double angle formula as follows by noting the famous square identity. Sine squared x plus cos squared x equals 1 for all angles x. Now, we derive that cos of 2 times A is cos squared A minus sine squared A. But I can replace sine squared A with 1 minus cos squared A, thanks to this identity here, right? Because if I get sine squared x by itself, I subtract cos squared x on both sides. Then I'll distribute out the negative 1, so it'll become cos squared A minus 1 minus minus, so plus cos squared A. So these two cos squared A's become 2 cos squared A minus 1. So that is the second version of the cosine double angle identity. Similarly, instead of replacing sine squared, I can replace cos squared. So if I get cos squared by itself here and subtract sine squared, that becomes 1 minus sine squared A. And then that becomes 1 minus sine squared A minus sine squared A. So there's two amounts of sine squared A that we are subtracting. And we are left with the third iteration of the cosine double angle identity. So cos 2 times an angle in its general form is cos squared A minus sine squared A. But that's also equivalent to 2 cos squared A minus 1. And that's also equivalent to 1 minus 2 sine squared A. All right, let's take an example. If we let's have a look at cos of 60 degrees. From special angles, we know that's a half. But I can write it in three different ways. So I could write it as cos of 2 times 30 degrees. So if I use this first general formula here, that's going to be cos squared of 30 degrees minus sine squared of 30 degrees. Then here again, cos of 2 times 30 degrees. In the second way, it's going to be 2 times cos squared 30 degrees minus 1. And then in the last way, it's going to be 1 minus 2 sine squared 30 degrees. So let's work out each of those and see what we get. So for the first one here, cos squared 30 minus sine squared 30. So remember what that means. Cos of 30 is a special angle, is root 3 over 2, and you're squaring it. Minus sine of 30 is a half, and you're squaring it. So if I square that, root 3 squared is 3, and 2 squared is 4, minus 1 squared is 1, 2 squared is 4. So I have 3 quarters minus a quarter is 2 quarters, which is a half. So that's correct. What about the second way? So the second way says you take 2 times cos of 30, which is a half, and you square it, and then you subtract 1. It's going to be 2 times a half squared is a quarter, minus 1. So you have 2 quarters minus 1. Sorry, cos of 30. That is root 3 over 2, not a half. So let's just correct that. Okay, so that's cos of 30 is root 3 over 2. So if I square root 3 over 2, it's going to be 3 over 4 minus 1 there. Okay, so 2 times 3 is 6 divided by 4 minus 1. Okay, 1 is essentially 4 over 4. So now I have it as common denominators. So 6 minus 4 is 2 over 4, and that's a half. So that's correct. Okay, and then lastly, from this one here, it's 1 minus 2 times sine squared 30. So now sine of 30 is a half, and you're squaring that. There's 1 minus 2 times. A half squared is a quarter. So you have a half minus 2 quarters, which is 1 minus a half, which is a half. Okay, so whether you use this one, or that one, in terms of the trigonometric identity for cosine double angles, you will get the same result. Why do we need 3? Well, depending on the trigonometric question that we're faced, we might see one of these 3 forms somewhere in the expression. So if we can identify one of those 3 forms, then we can just simply reduce it to cos of 2 times the angle. Okay, so this has been the cosine double angles introduction. We'll do some questions now regarding double angles. Awesome. I'll see you in the next one.